Okay, so this is 4.5. So now remember in 4.4 we had counting principles and the permutations and those things. So we were able to find the number of ways, for the given sequence of events. Now here we are going to use those counting principles and permutations things, you know, to find the probability. So here we are going to find probability in terms of counting principles. Okay, so in another word, how to apply those permutations and counting numbers principle in probability theory. That is the thing now we are going to look at. Okay, look at that example one. Find the probability of getting four aces when five cards are drawn from an ordinary deck of cards. Okay, so you are drawing five cards and you are looking for, four aces out of five. Okay, so in how many different ways you could be done, you have to figure out that first, right? Remember here, I'm going to find, you know, the probability of getting four aces when five cards are drawn. Okay, so you could think of this as the given event E, getting four aces out of five cards. So if this is the case, the question is simply finding P of E, right? So I'm going to use the formula for P of E we had, the empirical probability, remember? So the probability of E is given by N of E over N of S, right? So now the thing is, you need to figure out these two numbers, N of E and N of S. Okay. So let's find out these two numbers. First, let us figure out what NS means. Okay. So what is NS here? The number of possibilities, in my sample space. So I'm looking for five cards, right, from 52. So you are drawing five cards. In how many different ways this could be done? Well, you have 52 cards. You are choosing five at a time. How many different combinations you could, make? So that will give you the number of ways, right, from your sample space. That is simply 52 choose 5, right? So this much number of ways you could, draw 5 cards from given 52 cards. So that is my NS. Then what is N of E then? Or what is N of E here? The number of ways you could make 4 aces from 5 cards, right? So you are drawing 5 cards. So I'm looking for 4 aces. That means the remaining one may be anything, right, other than 4 aces. So this is none ace, right? So now that means when you draw 5 cards, you are basically doing, two things. First, you could think of this as event 1. The choosing, none is maybe event 2. Okay. So now ask yourself in how many different ways, this could be done. Choosing 4 aces and 1 none ace, right? Now here, if you have k1 number of possibilities for choosing, 4 aces, and if you have k2, possibilities choosing none ace, then when you multiply these two, then you will get total number of possibilities of choosing, 4 aces out of 5. So I'm going to find k1 and k2 first. Okay, what is k1? K1 is nothing but you are looking for 4 aces out of how many aces are there in your card pack? Remember, there are 4, right? Therefore, K1 is nothing but 4 choose 4. You are looking for aces out of given 4 aces, right? So in similar way, here you are looking for none ace, right? So what is the possibility of having this? So here, remember, there are 4 aces in my card pack and 48 remaining out of 52 are none ace, right? So I'm looking for one of them from this 48. Therefore, in how many different ways that could be done? That could be done in 48 choose one ways, right? In other words, there are 48 possibilities to choose the non-ace card, right? Remember, four of them are aces, remaining 48 non-ace. So 48 C1 is nothing but 48. Okay. In how many different ways you could find four aces out of four? Well, this is only one possibility because you have all four, you have chosen one, right? So this is one way. So therefore, my NE is simply the product of K1 times K2. My K1 is nothing but 4 choose 4 times my K2 is 48 choose 1. Therefore, plugging these two values into your formula, you will get the probability of E. So N of E is 4 choose 4 times 48 choose 1. This all over. My, the total number of possibilities in sample space is 52 in my, the card pack. Out of 52, I am looking for 5 different combinations. So this is my answer. So simplify this, and as I said earlier, 4C4 is 1. So you could type this in calculator if you want to check. Then times, and 48C1 is 48 over 52 C5. So this is the big number I'm writing as it is. Okay. So now type this all in your calculator and find out. So I'm finding that number. So 48 divided by 52 C5. So 52 C5. So I'm going to number 3 C5. So that is a very small probability. So it is very small. So if you want, you could give your answer in this form also. That is fine. So that's the way to find given probability. So make sure that you understand this whole the work, and I know this is not going to be easy, but anyway, so make sure that you practice this. Okay. So now let's move to the second example. The box contains 24 integrated circuits, 4 of which are defective, not good. If 4 are solved at random, find the following probabilities. Oh, you have a bunch of probabilities now. So let's find one by one the solutions. Part A. Remember, there's a box, right? There are 20 good circuits and 4 are not good, defective. Okay. So the thing is now, if 4 of them are solved, I don't know which 4, maybe good, maybe bad, maybe all mixed together. Find the following probability. The first one is find the probability of exactly 2 are defective. Okay. So what does mean by that? That means again I'm using NE over NS like earlier we did. We are finding now. Anyway, there are 4, circuits are solved. 2 should be exactly defective. That means the remaining 2 should be good, right? Therefore, you have to look for the 2 things like earlier we did. First, find, you need to find the 2 things, K1 and K2, right? So first I'm going to find NE over NS. My event E is nothing but, choosing exactly 2 defective. So if 2 defective, that means the remaining 2 should be good out of 4, right? So that means, remember now, in order to find this event says, 2 exactly good. That means 2 should be defective, right? And 2 should be good. That means basically you are looking for 2 different, events under each. So now ask yourself, how many ways you could, find this event happen? So how many ways you could choose 2 defective out of how many defective? Out of 4 defective. So that means this could be done in 4C2 ways, right? There are 4 defective, you are choosing 2 at a time. So this could happen in 4C2 ways. Remember, order is not important. You are just looking for different combinations, right? Times. So simply I'm finding here in me, okay? So that is 4C2 ways times times. Look at this one. In how many ways this could be done? Choosing two good from how many goods? From 20 goods. Therefore, that should be 20 choose 2. So this is basically my N of E. So that is 4 choose 2, choosing 2 defective, and 20 choose 2, choosing 2 goods. That is my N of E. So we could think of this is my K1 and this is my K2. Then this all over, NS. NS coming from my sample space. The sample space says that in total you are selling 4 out of 24. Therefore, that should be 24 choose 4. Okay, so figure out this answer. So this could be, I'm using calculator and I'm writing answer here. So if you do correctly, look at here, I got 0.107. So points, so very less probability. The second one is find the probability of none of them is effective, none is, sorry, defective. That means all of them are good, right? Therefore, how many different ways you could choose a good circuit? Remember, there are 20 together, good chips. Out of 20, I'm looking for 4. All of them are good. So that divide by the total number of ways is again 24, choose 4. Okay, so please find the answer of this. So this is B. And C, find the probability. All of them are defective. That means all 4 are not good, right? So in how many ways this could happen? All 4 are not good. Out of how many defective? 4 defective. Therefore, 4 choose 4 over 24 choose 4. So 4 choose 4 is actually 1 over 24 choose 4. So make sure that you find this number as well. And the last one, the probability of at least one defective. Okay, so remember, if you have at least, using a complement is always going to be easy. So if this is your event E, so the probability of event E, now I am changing that into a complement event E bar, right? If my event E is at least one defective, then my event E bar, the complement of this event, negation of this statement is going to be none of them. None of them is defective. That means what? That means all of them are good, right? That's the meaning, right? So I'm changing that, okay? So the probability of at least one defective is nothing but 1 minus the probability of none of them are defective. But this probability is already known, right? The probability of none of them is defective. So this is nothing but my problem part B, right? Problem part B says that probability of none of them is defective is 20 choose 4 over 24 choose 4. So that means this answer we already know. Therefore, my final answer is 1 minus the probability of none of them is defective. So this is part B. So plugging the part B answer, that is 20 choose 4 over 24 choose 4. Okay, now you could figure out this answer as well. So this is the way to find all 3 probabilities. So now let's move to the next one. A student needs to select 2 topics to write 2 term papers for a course. There are 8 topics in economics and 11 topics in science. Find the probability that she selects one topic in economics and the one topic is science to complete her assignments. Okay, so she need to choose 2 topics, right? Therefore, the question is now finding the probability of what? You need to find the probability of C selecting one topic from economics. So one in economic and one should come from science. So this is the events he wants. If you look at that is event E. So I'm using the formula. The probability of E is n of E over n of S. Okay. So now let us figure out n of E first. Remember the possibilities of having this event E. So E is choosing one econ and one science. So that means you need to look at two different events, right? First, let us find the number of ways he could choose, a topic in econ. He need one topic from economics. How many topics are there in total in economics? So if you look at in economics, he has eight topics. So eight topics. So he needs to choose one of these eight. So this is the number of ways she could choose, the one economic topic out of eight. This is my K1. So you need to multiply this with the second. The second one, so you have to choose one science topic out of 11. That is going to be 11 choose one. So that is my N of E. Okay. But what is N of S then? N of S coming from the samples, all the collections, right? So you need to choose two topics in a row out of how many topics in total? In total, she has 11 from science and 8 topics from economics. So she has, 19 topics in total. So that means out of 19, she has to choose now two. So this is going to be my, the number of possibilities in sample space. So ask yourself in how many ways you could choose in total. So sample space means you have to look in total, right? In total, there are 19 topics. In total, she has to choose two. So that is 19 choose two ways. This could be done. Therefore, these two numbers simply plug in here. So in is 8C1 times 11C1 over 19C2. So take your calculator and type this and find out that answer. So I'm leaving the remaining problems to you guys, and why don't you try this, and I will discuss some of these problems in our class meetings. Okay.